Hello everyone. In the previous video, we studied how to measure cardiac output, and in this video, we are going to learn about what actually cardiac output is. Okay, so first, let me draw a diagram. Uh, Here is my complete body. It is supplied by a chamber of heart called the left ventricle, which is again supplied by another chamber of heart called left atrium. Okay, similarly, blood goes from there, from the body to the right atrium, and from here to the right ventricle. This is our lung. Okay, so actually blood flows in this manner. So you can see that in each circulation, blood actually passes twice from the heart. This actually is a single structure, right? That is why we call the circulation in human as double circulation. I hope you know this much. Now we see that here I only need this much. Blood actually goes from here, 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 here. We have seen similar thing in electricity. This is what we call series connection. Okay, this is a series connection. Suppose I have one wire and I have another wire. If all the current that is flowing through this wire also has to pass through this wire, then this connection is known as series connection. The same is the case here. So whatever blood is flowing through right ventricle also flows through left ventricle in one complete circulation. Okay, so we define cardiac output as amount of blood that flows through either of the ventricle in 1 minute. I hope you get this. Okay, cardiac output is the amount of blood that flows through either of the ventricle in 1 minute. So suppose this is my heart. Okay, from here my aorta is leaving, from here my two vena cava are opening. Okay, so whatever blood that is coming here, whatever blood which is flowing from here, whatever blood which is leaving here, whatever blood that is entering here, and whatever blood that is leaving from here is exactly the same. I hope you get this much. Moving on, cardiac output. How we define cardiac output? Well, definition is, I think it is clear. Now, a few more terms that we're going to discuss. Stroke volume, or SV. Volume of blood pumped after a single systolic contraction of left ventricle. We arbitrarily take left ventricle, but this holds true for every structure. Okay, few more terms. EDV or end diastolic volume. Okay, so suppose my heart is contracting. Okay, when my heart is completely contracted and when it relaxes, my drawing is very poor. This is IVC, this is SVC. Okay, IVC, SVC. Similarly, this is right ventricle, right atrium. Okay, so similarly here there is left atrium, pulmonary veins are opening here and it is opening into left ventricle, which is going here as aorta. Alright, so when the heart is completely contracted and after it relaxes, the volume of blood in the left ventricle at the end of ventricular diastole. Okay, similarly end systolic volume is volume of blood in left ventricle after ventricular systole. Alright, now listen to me. Heart left ventricle is completely filled. Okay, that is, this is its EDV. Now it contracts and some amount of blood leaves the heart through aorta. This is called stroke volume. Okay, and the amount which left, this is called end systolic volume. I hope you get this. So systolic volume equals end diastolic volume minus end systolic volume. Here I must also include one more term, that is ejection fraction. Ejection fraction, suppose, what do you understand by this term? The amount, the fraction of blood that is ejected. So its definition is simple. Ejected blood is what? Stroke volume out of total blood, that is EDV. We can also write it as EDV minus ESV upon EDV 1 minus ESV upon EDV. I hope you get this much. So this is our stroke volume and its relation with end diastolic volume and end systolic volume. Okay. There is one more thing that we have to cover later, that is Frank-Starling law. I will cover that portion later on. Okay. So stroke volume is the amount of blood that is pumped out of the ventricle, after a single systolic contraction. I hope you get this word single. Now, there's something called heart rate, which you all must be knowing very well. Whenever you measure pulse rate, that is the same as heart rate. Pulse rate, heart rate, until and unless the heart is healthy. That means there is no conditions like fibrillations or flutters. As long as these conditions are not present, then pulse rate is same as heart rate. Okay. So heart rate normally it is around 70 to 90 beats per minute. Average we take it around 72 beats per minute. Similarly, the value of normal values of SV is around 70 ml, EDV is around 120 to 130 ml, and ESV is around 50 to 60 ml. So ejection fraction, the normal value ranges around 65%. Okay. If ejection fraction is lower than this, this means the patient is suffering from either stenosis of the valve or regurgitation. Okay. So now, since we know the normal values, let us proceed with what is cardiac output and its relation with stroke volume and heart rate. So cardiac output, as we know, cardiac output is nothing but the amount of blood pumped in 1 minute. Okay. And we know that the amount of blood pumped in a single contraction, it is known as stroke volume. So cardiac output has some relation with stroke volume. If stroke volume increases, definitely you know that cardiac output will also increase. If the amount of blood that is pumped after one contraction, it increases, the total blood that will be pumped after 1 minute, it will also increase. Similarly, if heart rate increases, cardiac output will also increase. So cardiac output is nothing but stroke volume into heart rate. Okay. Amount of blood pumped in one contraction and number of contractions in 1 minute, that will be amount of blood pumped will in 1 minute. Okay. So here let me give you a brief of the topic that we are going to study in the next video, that is regulation of cardiac output. So, if I have to regulate my cardiac output, I can do it in two ways. Either I can regulate my stroke volume, alright, or I could just regulate my heart rate. This way, I can increase my cardiac output or even decrease my cardiac output. So, with this, we come to an end of the session. I will continue the video, and in the next video, we'll be studying this topic, that is the regulation of cardiac output, in much more detail. Thank you very much.